Oh, I should also bring in the teleconference.
Welcome to the CCC Confer Conference Center. For security verification, please enter your passcode followed by the pound or hash key. Please hold. Thank you. Your passcode is please. When you hear the tone, you will be the first person to join the meeting. The line will be silent until another person joins.
Okay, everything's connected. What's going to be really difficult is that I'm going to have to try to write with the mouse. None of my other technology seems to be working, and since my move, I can't find anything. So I have, at this moment, been unsuccessful in locating the pen for the other pad that I use when my tablet's not working. So I'm going to be a little bit limited in being able to write out problems for you, solutions. But I'll be still happy to address any questions that you may have. Okay, so do we have any questions? I don't even know what to ask at this point, I guess. What will we need to know on chapters 5 and 6? What will you need to know on chapters 5 and 6? Not a lot. Have you looked at the final review guide? I don't really think there's much reference to the final, to chapters 5 and 6. Let me look, do a quick look here. Okay, there are no multiple choice questions on your final exam. So your exam is really built around problem solving. So if you've done the homework for chapters 5 and 6 and submitted it, that's probably really the last you're going to see of the chapter 5 and 6 information for the semester. Okay, I'm holding these sessions for you guys. So there's really not much else for me to tell you at this point. I can try to go through a couple of problems if that's helpful, but if you haven't, no, Kathy, there will be no chapter 5 and 6 problems on the final. If you look at the final study guide, those are the types of problems that you will see on the final. Okay. Reminder, we are still meeting tomorrow. There are a few of you coming at 9 o'clock in the morning, and there are at least one of you coming at 12:15 tomorrow. Please remember that I have a new office location. I am now in Village 112. Please just come here to my office. There is plenty of room for us to work here in the office. I have a whiteboard up. And in addition to that, all the equipment in here, so we will just work out of this room. I'm not going to go ahead and take a classroom. The Village 112, the Village are those really odd-looking trailer-like buildings just across from Towsley and where my office was before, up behind that really lovely restroom right outside of Towsley, you know, the little modular restroom. Right up behind that, up that little slope, are a bunch of those weird modular-looking buildings, trailer-like buildings. I'm in the very last one, pretty much right across from where my old office was. So essentially the same place I used to be, just a little further over. Okay, page 2 of the study guide. Hector, I will do my best to go through these. However, I do not have a writing implement to write stuff. So I'm going to have to write with the mouse, which is going to be a very unique experience, I'm sure. So yes, I can go through some of those for you. Let me do it this way, since I can't write things out very well. Hector, why don't you tell me what your question is on the problem. Where did you get stuck when you worked the problem? And then maybe I can help clarify it that way and try with the mouse to put some of it here on the slide so that you can see it. To answer Kathy's question, yes, tomorrow is for working with the equipment. Since it's already been 2-3 weeks since you last touched the equipment, you're welcome to come in and practice leveling, redo your pacing, practice reading angles, you know, whatever it is, or all of it, whatever it is you would like to do. Zamp will be here as well. So we'll have both he and I to be able to help you. I'm also available to answer and go through problems if you want to solve problems while you're here, if you have questions on the study guide problems or just from homeworks, whatever. It's really, tomorrow is really about assisting you with what you need help with, whether that's working on the equipment, going over problems, or both. That's what we're here for tomorrow. Hey, guess what? I finally found the pen. Okay, so this is half a step up from the mouse, so I can write a little bit better. Yes, tell me about it. But it's still not as good as the tablet, and that's not great either. So bear with me. But I will do my best to write some of the stuff out here. Compute and tabulate the bearings and azimuths problem. Oh, number 2 on the page. Okay. Number 2 on which page, Hector? I'm looking at the final. Oh, okay, never mind. Sorry. Hang on, I'm getting to it here. I'm getting to the problem. There we go. Azimuths and bearings. Okay, 5 interior angles of a 6-sided closed polygon traverse were measured as indicated in the table below. Compute the angle at F, which was not measured. So we know that, okay, let's try this here. we know that n minus 2 times 180 degrees will tell us the total number of angles, the total number of degrees within our figure. And we have a 6-sided figure. So 6 minus 2 times 180 degrees is equal to 720 degrees. So we know that the interior angles of our 6-sided figure must equal 720 degrees. If you sum the angles that were provided, come over here we go. If you sum, that's a sigma, the angles that were provided, they are equal to 594 degrees, 15 minutes, 32 seconds. So to solve for the angle F that was not measured, you take 720 degrees and you subtract the 594, 1532. In order to do that, 720 becomes 719. This becomes 59, and this becomes 60, right? Because 60 seconds becomes 1 minute, 1 minute becomes 1 degree, brings you back up to the 720. And now you can subtract these. So this gives you 28. This gives you 44. And this gives you 125. So angle F is equal to 125 degrees, 44 minutes, 28 seconds. Okay. All right. Let's go to a new page over here. The next azimuth and bearing question is course AB of a 5-sided traverse runs due north. From the given balanced interior angles to the right, compute and tabulate the bearings or azimuths from north for each side of the traverse. Okay, this is key. There are a number of you that didn't get this right on the exam because you did not get the angles to the right portion. So, and this is going to be pretty comical, but I will do my best here to try to draft this out a little bit. So AB runs due north. Oh, I don't want it way over there. Want it over, let's just put it right here. So there's A. What is going on here? Need a pen. Pen, thank you. All right. So A. Why am I writing? Oh, now I'm writing. A to B. I'm having difficulties all of a sudden here. Go back to the pen. So here's A, and there's B, and that runs due north. Okay? You're turning angles to the right. What does that mean? It means that when you occupy B, you sight back to A, and you're going to turn to the right. So the angle at B is 107 degrees. So let me see if I can kind of sort of do this. Since this is due north, then due west, would be 90, so 107, I don't know, it's going to be somewhere maybe there. That's a little too steep, but I'm going with it. So there's C, and then this angle here is the 107 degrees and change. Now you're at angle C, and you're going to turn an angle to the right, so you're going to occupy C, you're going to sight back to B, and this angle is 86 degrees. So roughly there, roughly that's roughly 90, so we're going to call this right here 86. And there's D, right? Because you're turning to the right. Okay? Angle D is 99 degrees. Again, you sight back to C, you're going to turn to the right. So angle D is going to be roughly here. And I know I'm going to screw this up. Okay. Angle E, I think, is going to have to be over here somewhere. So there's E, and then sight back to D, turn 120 degrees to the right, and join back to A. Okay? If I could erase that, I would. There you go. And that's a really bad sketch, but I'm doing the best I can here. So that's roughly what your figure would look like. So now if you're going to calculate all of your azimuths around the whole figure, well, if I can get my pen over here, there we go. We know that the azimuth of A to B is 0 degrees, right? It's 0 because it's due north. Okay? So if we're going to calculate this in a counterclockwise direction, that way, then in order for us to get the azimuth of B to C, we need the azimuth of B to A. The azimuth of B to A, we're going to add 180 degrees. So we're going to get 180 degrees, and that's now the azimuth of B to A. We're then going to sorry, having a little tough technical difficulties here. There we go. We're then going to add our angle at B, which we know to be 107 degrees, 54 minutes, and 36 seconds. When you add those together, you're now going to get the azimuth of B to C, which is 287 degrees, 54 minutes, 36 seconds. In order to get the azimuth of C to D, we need the azimuth of C to B. So I'm going to subtract 180. You could go ahead and add 180. It just means you're going to end up over 360 and you'll have to subtract that back out. You'll end up in the same place. It'll just take an extra step. That brings you back to 107, 54, 36. That is now the azimuth of C to B. We're now going to add the angle at C, which is 86 degrees, 22 minutes, 33 seconds. When you add that up, you're going to get 194 degrees, 17 minutes, 9 seconds. That is now the azimuth of C to D. here. Okay, and that's about right. If you dropped your meridian in here, right, your north meridian, this is 180. I'd buy that that's 194 given my really cruddy drawing. So now to do D to E, I need the back azimuth of D to C. To get that, I am once again going to subtract 180 degrees. Again, I don't want to have to go over 360 and then pull that back out. So that is now going to give me 14 degrees, 17 minutes, 9 seconds. That is now the azimuth of D to C. I'm going to add my angle at D, which is 99 degrees, 2 minutes, 17 seconds. That's going to give me 113 degrees, 19 minutes, 26 seconds, and that is now my azimuth of D to E. Okay. To get the azimuth of E to A, I'm now going to add 180 degrees because I need the azimuth of E to D. So that gives me 293 degrees, 19 minutes, 26 seconds. That's now the azimuth of E to D. We're going to go ahead and add the angle at E, which is, oops, back over here, 120 degrees, 39 minutes, 6 seconds. Gives us 413 degrees, 58 minutes, 32 seconds, but we have to subtract out our 360 because we went past the circle. That leaves us 53 degrees, and I'll rewrite this in a second, 58 minutes, 32 seconds. That's our azimuth of E to A. So I'm going to come over here and write it up over here. So the azimuth of E to A, 53 degrees, 58 minutes, 32 seconds. We theoretically could stop here because we have now done what was asked. We went ahead and got the azimuth of each side of the traverse. But it's really not a good idea to do that. It's best that you check and make sure that your loop closes. So we're going to go ahead and add 100, oh, for goodness sake. We're going to go ahead and add 180 degrees, which gives us 233 degrees, 58 minutes, 32 seconds. And that is now the azimuth of A to E. We're going to add the angle at A. There it is, 126 degrees, 1 minute, 28 seconds. And this should now give you the azimuth of A to B. And when we add this up, we get 60 seconds, 59 minutes, and 359 degrees. 60 seconds becomes 1 minute. 59 minutes becomes 60 minutes. 60 minutes becomes 360 degrees, which is the same as saying 0 degrees, 0 minutes, 0 seconds. So we're good. Okay. The real key to these problems at this point is remembering what an angle to the right is. Remembering that you sight back and you're standing here, you're looking here, this is your right-hand side. Hector, did I address your questions? Okay. Anybody else? It's fine if you guys want to wait till tomorrow and ask questions when you come in tomorrow. John, I know you aren't able to come tomorrow. Is there anything specific you'd like me to address now? Okay. Okay, I would get it. I get that you'll have more questions. There are still ample opportunities to ask more questions. We obviously have time tomorrow. For those of you that are coming tomorrow, I'd be happy to work out problems for you. And then we also have one more live session before the final, 2 nights before, I believe. So I'm double checking the schedule right now as we speak, just to make sure I'm not completely losing my mind. Yes, Wednesday, 5th of December from 9 to 10 p.m. We have another live session. Tomorrow, again, feel free to come in at 9 or at 12:15, and we'll address any questions you have, and it's a good opportunity for you to work on the equipment. This is the only opportunity before the final on the 7th to work with the equipment, but again, I will be available for the live session on Wednesday the 5th, and hopefully answer any questions that you have. Oh, I did. Did I change the time on the 5th to 5 to 6? Is that, Kathy, is that what you're saying? Oh, I'm flexible to do that. If you guys would rather do 5 to 6, that's great for me. I certainly don't have a problem doing that. Let me double check it now that I've said that out loud. But I think, yeah, I can do 5 to 6 instead of the late hour. Did anybody else think that was changed? Did I say that? It's possible I said that. I'm having trouble today remembering what I had for lunch. It's been a crazy, crazy day. So I will post it in Blackboard and ask everyone what they would like to do. And if you would like me to change it to 5 o'clock, if that's better for most people, I'll be happy to do that. It really doesn't matter to me. Okay. All right. And then, Josh, I saw your comment here. Are you all right? Are you still going to make it here tomorrow? Are you in one piece? Oh, I'm sorry to hear that. I hope she's doing okay. Josh's grandmother was in an accident, so. Okay. We're coming up on 40 minutes in, and I try not to abuse your kindness of joining my live sessions, so I'd be happy to do another problem now if you'd like, although some of them can be a little bit long. Or if you would prefer, we can just go through them in person tomorrow. I am completely flexible. I can see someone's typing, so I'm just waiting a moment here. Oh, good. Josh says Grandma's fine. She's just got bruises on her chest, so that's good news. Tomorrow is good. Okay. Then we'll go ahead and call it here, and I look forward to seeing you all in the morning. Again, remember, it's Village 112. I'll be looking out for you guys. There's Aunt Will, and we'll be waving, and so that you find your way over here. But I think we can make it work here in the office, and then take the equipment out and do what we need to do. And we'll just keep moving forward from there. Okay? So I will see several of you in the morning. And I'm going to go ahead and stop the recording.